Hi there, this is exercise 7D.2. Last time we looked at partial fractions with quadratic denominators, and today I want to take that on a bit further. This is what we were doing last time when we had, say, a quadratic factor like x squared plus, it doesn't matter what it is, 5. You ended up having to write bx plus c above it, because otherwise you're missing potential coefficients that you'll need. So just remember that, please. And we've got a question here which will turn into, we'll use it for other things, but this will be a good reminder then. So we would do the x squared minus x minus 5. It says write it as partial fraction, so I'll do that, x squared plus 4, x minus 1. And this is equivalent then to, so above the x squared plus 4, I'm going to need to write ax plus b. It's a quadratic, so I do one power less than it. This is x squared plus 4. The x minus 1 just is a linear factor, so I can just do that. And so when I put the right hand side over the same denominator as that, so an x squared plus 4x minus 1, and that effectively gives me on this side an ax plus b times by the x minus 1 plus c times by the x squared plus 4. And you will recall I don't really like writing the right hand side with all the bottoms and stuff, so I just do it like that instead. And now I basically set x equal to a number. The only one I think I can use is x equals 1. X equals 1 into this gives 1 minus 1, and it disappears, minus 5. And 1 into there goes, that's the reason for doing that, and I think I get 5c, so therefore c is minus 1. And you will recall, hopefully, that we get the other coefficients by looking at the x squared terms. X squared is 1, and when I do this, I think I get ax squared plus c. So I think c must equal 1, so that, oh no, that's rubbish. So c was minus 1. Move that over, a is 2, that's what it's telling me. So if a is 2, and then I look at the numbers, and if you look at the numbers, I've got minus 5 on the left, and here I think I'll get a times by minus 1, no it's not a times by, it's b times by the minus 1, so minus b, I get 4c, and 4c therefore is minus 5 equals minus b minus 4, and if I make more positive, I reckon b is 1. As an answer. So how write this? So I've got a over ax plus b over. So I've got 2x plus b. What was b? b was 1 over the x squared plus 4 plus a minus 1 over the x minus 1. There you go. So, and that can be written like that, and also interestingly like that. Don't forget these, we will need these. When we integrate expressions like this, 1 over a squared plus x squared, we get inverse tans. You should remember that from previous videos. And also, if you integrate something where it's a fraction, but the bottom of the fraction can be differentiated to give you the top, that's the inverse, that's the log of the bottom. So those two will come in useful. So when they're going to integrate, because it says now use this to find the integral of this, which of course we've just done. So it effectively becomes the integral of the first one over x squared plus 4 minus integral of this one dx. Now this at the moment we can't do, but you can do it if you realise that the x squared plus 4, it's 2x divided by it, and it's also a 1 divided by it. So we can split it into 3 parts, 2x over x squared plus 4 plus 1 over x squared plus 4. That's the trick you need to be able to do these. Now this first one is just the perfect thing that I was talking about just now. It's, if you differentiate the bottom, you get the top. So it's the log of x squared plus 4. Plus, now this is actually one of those inverse tan ones. And because that's 4, my a value is 2. So I'm going to get plus half of the inverse tan of, now it's always x over 2, x over a, so in this case it's x over 2, plus the log, or it's a minus, nearly went wrong there, minus the log Now if I differentiate, the reason I said log, if I differentiate x minus 1 I get 1. So it's minus the log of x minus 1 plus a constant. And I can join these two up. I'm fairly sure the answer will have done that. That's what I wrote. Yes, there it is. It's all joined together nicely for me. And notice it said minus, so it becomes a divide. Next question, it says express this as partial fractions. Okay, let's go for it. So we've got 3x over x minus 1, x squared plus 2. So again, we just get into this habit of it's a over the linear one plus bx plus c over the quadratic. I'm going to write the right-hand side in the same format with the bottom as the left-hand side. So that gives me a lots of x squared plus 2 plus bx plus c lots of the x minus 1. And if I now set x equal to 1, because of that bracket there, I get 3 on the left-hand side. 1 goes in here, I reckon that gives me 3a, and that disappears, a is 1, so it's perfect. Look at the x squared terms, I think, initially. But no x squared on the left-hand side. I've got an a plus a b, so I reckon b must be minus 1. And then if I look at the numbers, on the left-hand side there's no number at all. And on this I get 2a minus c. So 2a is 2. And I reckon c therefore must be equal to 2. So writing this in partial fractions, I get a, which was 1 over the x minus 1, plus b, well it's actually not very nice, minus x plus 2. You'd probably write 2 minus x if I was doing this properly. Already written it, so I'll leave it like that. But that's the answer. Which is lucky because that's what they've got as well. And so having got that, they now want me to integrate. It's quite common to get this second part once you've done it. So let's just remind ourselves, we've got 1 over x minus 1. So really this is integrate 1 over x minus 1. And what else did I have? It was plus that. So plus minus x plus 2 over the x squared plus 2 dx. And I think I need the same trick as I just had. I think I've got to split this into the integral of 1 over x minus 1, that's fine, minus x over the x squared plus 2, so that's got to be integrated as well, plus 2 over x squared plus 2 dx. That's what I'm integrating, all three of those things. And so this one is a straightforward logarithm. We've seen that, I think we saw that same example just now. This one, if I differentiate the bottom, I get 2x. It's the same trick as last time. Oh, apart from it doesn't say 2x, I've only got x. I reckon it's minus a half of the log of the bottom. And this one is, I think it's one of those inverse tan ones again. I think it's 2 integral of 1 over x squared plus 2. Oops, what happened there? So that will give me 2 times by 1 over root 2, and that's because a effectively is root 2, times the inverse tan of x over the a, which is root 2, plus a constant. And 2 over root 2 is root 2, so I'm hoping I've got the log minus the log plus root 2. Oh, interestingly, they've written arctan instead of inverse tan, but it's the same thing. Everything else is the same. And notice they didn't bother putting them together, they just left them separately. So the final example for us, we've got a dy by dx equals that, and it wants me to find an expression for y. Now you find that by integrating. You get rid of the dy by dx by integrating. I don't think I can integrate it without partial fractions. So my very first thought is, let's find partial fractions for this. And I notice that looks like a quadratic. I stress the word looks like a quadratic. This second one I think is a quadratic. This one can't be factorised, you see. That's why I think I can't, that's going to have to stay like this. But this can be factorised. This really is x plus 2, x minus 2. And bear that in mind, because if I get rid of that and now write that, this then becomes A over the first one plus B over the second one plus, now the third one is a quadratic, so I need cx plus d over x squared plus 4x plus 5. Okay, so let's rewrite the right hand side with the same denominators I've got on the left. That's over x plus 2, so I think I need to gain an x minus 2 and the quadratic. The b, I think, gains the x plus 2 and the quadratic. And then the cx plus d gains the x plus 2 and the x minus 2. That's a lot of writing, isn't it? And so let's put values in for x. X equals 2 first of all. If x equals 2, I reckon I get 68 there. But when x is 2, that all disappears and that one disappears. So I'm only left with this. It becomes b times by 4 times by, that's 4 plus 12. When I add that one, that's 17. That's, alright, that's 68b equals 68b equals 1. Let's pick x is minus 2. That will get rid of the other bracket. So that one will stay. Minus 2 into that goes 4. So, as I say, that will stay. It's a times by minus 4. And if you do that, that's 1. That disappears. So I actually get minus 4a equals 4, or a is minus 1. Now I'm going to have to, I was going to say do the x squared terms, and actually I've got to do x cubed terms on this because that's the highest power. And it's easy if you do the highest power. So on the left hand side I've got no x cubes. If I times this out, I get a plus a b plus a c. So what's a plus b? That's 0. So c must be, oh, c is 0. You occasionally get ones which just simplify it massively. And then I'll look at the numbers. If I look at the numbers, I get, on the left hand side I get 36. The numbers are 2 5s are 10, so that's minus 10a, plus I think 10b. And on this one I get minus 4d. So that's 36, that's 20 when you do that, check it. So I reckon 16 is minus 4d, or d is minus 4. So writing that as an expression looks right. So I now need to integrate this thing. Well, okay, then let's go for it. Y therefore is, well, the first one's easy. If I differentiate x minus 2, I get 1, so that's the log of x minus 2. And minus the log of x plus 2, I think, because if I differentiate x plus 2, I also get 1. This one, I think, it's one of those ones where I've got to write u equal x plus 2. Because if u equals x plus 2, then this becomes the integral of 4 over u squared. Now, if I do it x plus 2 all squared, complete the square, I'll get x squared plus 4x plus 4. So I think I need to add on 1. I want to write dx, but of course I can't. Du by dx equals 1. So actually du equals dx. I can write du. And that equals minus, because it says minus 4 lots of the inverse tan of u over 1. And that should be over 1 as well, but I'm not bothering writing it. Plus a constant. So the only thing I've got to do now is join them together. Log of x minus 2 over the x plus 2, and write it as minus 4 inverse tan of that rather horrible bottom. Plus a constant. Let's see if the answer agrees. Oh, that. Oh, silly me, yes. That was a bad mistake. You always write u plus a. My u was that. That was a bad mistake. So it becomes x plus 2. Right, now I'm happy. So I want you to have a look at some exercise questions for me. Exercise 7D. This is further maths. So any questions you have, perhaps save them to when I see you in a couple of weeks. All the best.